All right, well, my name is Christopher Pohorecki. I am from Ridgeway High School, and this year I got to go to Oklahoma State University for aerospace engineering and unmanned aerial research, which is basically drones. So this year, us interns were given the project of creating a bicopter. So a bicopter is basically a plane and a helicopter combined. So what this means is the bicopter takes off vertically just like a helicopter, and then by angling its motors, it transitions into horizontal flight just like a normal plane would, and then back into vertical flight for landing, just like a helicopter would. So one reason we would want this is for planetary exploration. Right now, NASA has been trying to explore Mars by sending these rovers, and although they're really good, the rovers move at 1/30th the human walking speed, which is just insanely slow. And throughout the past few years, they've been able to move like a mile. So not much is done. So we would use a bicopter to, be able to fly around faster and over obstacles. So as you can see from these poor drawings, we started by, brainstorming and thinking what we wanted it to look like. And we had different orientations of the motors and different wing combinations. And we ended up, pitching all these designs up to our mentors, and they were able to give us some pretty good advice on what would and wouldn't work. And then right after that, we kind of just agreed on one, kind of brought our ideas all together and, made one really good design. And then after that, we ordered a bunch of parts because we had a good amount of funding behind our design. So we were able to order as many parts as we wanted. As long as it was necessary, we got it. So we got motors, servos, all that cool stuff. So then we got on to working with Solidworks. This was kind of the hardest part. Solidworks is a 3D designing software that you can use for printing as well. And it has a million buttons, and it took us a while to figure out how to, work. So this is actually our final render right here. And right over there is one of our failed prints. That is one of our thrust vectoring towers, and each one of those took about 9 hours, and we printed about 9 of those, and those come in pairs of 2. So we wasted a lot of filament and time, but it was good. We got to learn a lot and figured out how to structure things properly. So once we received our parts, we got to do a bunch of testing. First, we did some motor testing to see how much thrust it produced. So by using a dynamometer, we were actually able to try out different motors and different configurations with props. This was actually super fun because we got to kind of mess around and make some cool noises and make things fly around inside a room. And this ended up being kind of dangerous because we had a 20-inch prop spinning at several thousand RPMs, and that could chop off your arm. One of my professors actually had a finger chopped off from a prop. So he... Oh, no, 2 years ago or so? Yeah, that would have been traumatic. So right down over there is one of our thrust vectoring towers, and that's actually what angles the motors. So that is what makes the plane transition from flight. And that was pretty complex. It took a lot of, tuning and a lot of, printing because there's a lot of structure and complexity in the way it rotates. Yeah. So then we got on to wing construction, and it looks like we're using cardboard in here, but it's not cardboard. It's something called foam board. It's this pretty waterproof and rigid material, and it was super, super good because it's super lightweight and it's cheap. So we weren't using these complex carbon fiber wings, even though we wanted to. They wouldn't let us. And this was super customizable because we could cut into it. I built it out of carbon fiber rods and these wood struts, which we could just drill onto. And right down there is our final product of our bicopter. And it's about this big, it's about 1 meter. So these are the results. Our first flight did not look that good. That's our 30th try. First time, it flew up 20 feet and then instantly dive bombed and blew up into a million pieces. So didn't really have a chance there. But after some like real tuning and a bunch of trial and error with the gyroscopes and mounting it correctly, it worked off really well. And one cool thing is like 4 years of interns tried this project and they all failed. They couldn't get it to fly because the center of gravity was way too low or high, and ours works perfectly. So that was pretty cool. Yeah. And then outside of the lab, I got to commute on this cool electric skateboard. I got about 150 miles on that thing going back and forth from the lab to my house because nobody wanted to give rides. And then I went to Oklahoma City and did a bunch of good shopping there. Trader Joe's, which is an awesome place if you're like a college student. So pretty awesome. Yeah. And I'd just like to say a big thank you to Sarah Holbrook, everyone at the USRI laboratory. That's where I worked. It was super helpful. If you ever ask for help, they would instantly help you. And everyone at Pinhead for getting me such a cool internship.